Alright guys, today we are talking about solving absolute value inequalities. Okay, so we solved regular absolute value problems last week. Now we're specifically talking about inequalities because they're a little bit different. So let's talk about this first case. So this is an example. The absolute value of x is greater than or equal to 7. So just like when we were solving regular absolute values, we have to set up two cases. We have the positive case, so x is greater than or equal to 7. And we have the negative case, so negative x is greater than or equal to 7. From here, we just solve. Well, the right is already solved. Divide by -1 on both sides on the other one, and we'll get x. But remember, because we divided by negative, we have to flip the sign. So x is less than or equal to -7. So then if we were to graph this, we have positive 7 out here. We have -7 down here. And then x is greater than positive 7, so we're going to the right. And then x is less than or equal to -7, so we're going to the left. If we wrote this in interval notation, it would be -infinity to -7, bracket, union, bracket 7 to positive infinity. Okay. As you can see here, because they're pointed in two different directions, this is a big old OR statement right here. Let's take a look at the next one. So this one is the absolute value of x is less than or equal to 4. So our two cases is x less than or equal to 4 and negative x less than or equal to 4. So the left side's already solved. Divide by -1 on the right side. We get x is greater than or equal to -4. And as you can see, well, x is less than or equal to 4, and x is greater than or equal to -4. So then we go -4, we go +4, and we're going bigger from -4, but then we also have to be less than +4. So then this is our AND statement, okay? So it can also be written as -4 less than or equal to x less than or equal to +4. So then in order to write this interval notation, we would go -4 to 4 with brackets on both sides because it's closed circle. So what does this tell us? As you can see, we had a greater than symbol here. So then greater than is OR, and then less than is AND. The way I remember this, you can think greater stands for OR, less than stands for AND. Okay? So, just something to be wary of. And the way I'm reading this is the alligator here is eating the X versus the alligator is eating the number. Okay? So, let's keep going. As we said, steps, isolate, create your two cases, solve both sides, and then with inequalities we have to graph. So let's do some examples. So isolated inequality, already done. So then we're going to say x plus 7 or x plus 6 is greater than 7. Okay? Because this is a greater than sign, it's going to be an OR statement. So OR negative x plus 6 is greater than 7. So then we solve for x on the left side, we subtract 6, we get x is greater than 1. On the other side, we divide by -1, we get x plus 6 is less than -7. Subtract 6, and we get x is less than -13. So x is greater than 1, so 1 is right here, and we're going greater than, maybe, greater than. And then it says x is less than -13. So open circle going less than right there. How we would write this? -infinity, -13, union 1 to infinity. Okay? So this one is a less than symbol. So we're talking about an and here. So this is an and. The way you can actually write your ands actually, we'll just keep it like this, okay? So positive case, 2x minus 3 less than 19. Negative case, -2x minus 3 less than 19. And then in both cases, we're just going to solve, right? So add 3. 2x is less than 22. Divide by 2, x is less than 11. Divide by negative 1 from both sides, we get 2x minus 3 is, greater than negative 19. Add 3. 2x is greater than negative 8. 16. Math. Divide by 2. X is greater than negative 8. So then our and statement is going to be x in the middle, 11 on the right because that's the higher one, negative 8 on the left because that's the lower one. So then we fill this in, negative 8, open circle, positive 11 is going to be right there, open circle. And then we just connect those two things. Interval notation would say negative 8 to 11, both with parentheses because there's no equal sign. All right, on to page 2. So, first thing we always have to do in these problems, guys, is we have to isolate. So we need to isolate this, multiply 4 on both sides. Going to give us x minus 1 plus 10 greater than or equal to 8. Finish isolating, subtract the 10. X minus 1 is greater than or equal to negative 2. Okay. So from here, right, we're isolated. So then we can break it up into two different types. So x minus 1 is greater than or equal to negative 2. Negative x minus 1 is greater than or equal to negative 2. And then we solve. Add 1 to both sides. X is greater than or equal to negative 1. And in the other case, we divide by negative 1. X minus 1 is less than or equal to 2. Add 1. X is less than or equal to 3. So let's take a look at this. This is a greater, so then this is an or. So it says x is greater than or equal to negative 1, or x is less than or equal to 3. So if we were drawing that, we would have negative 1 here, and it would be going this way. And then we have positive 3 here, and it would be going this way. Okay? So this is actually a special answer right here, guys. The answer for this question is actually all real numbers. And we can actually learn that by looking at this equation right here. So maybe we got to this point and you were like, that's kind of weird. It is weird, right? An absolute value greater than a negative number. When is this going to be true? It's always true, right? Absolute value always has to be greater than a negative number. So because it's always true, then our answer is all real numbers. If we were writing that in interval notation, it would be negative infinity to positive infinity. Okay, so number 3, this is a special case, right? It can happen, okay, that we get all real numbers. Let's take a look at number 4. So isolate first, subtract 7 from both sides. Negative 6, absolute value, negative 5x is greater than 30. Divide by negative 6 from both sides. You get negative 5x is now going to be less than, the absolute value of negative 5x is going to be less than negative 5. Okay? Hopefully, when I said that, you were like, wait a second, because an absolute value being less than a negative number, when is that possible? Never, right? So this would be no solution. Okay? And that's because an absolute value always has to be bigger than a negative number. It can never be negative or smaller. Or it can never be 0 or it can never be a negative number, right? Absolute value cannot be negative. Therefore, it can't be smaller than a negative number. So we wouldn't write anything on the graph or the interval notation in this case. Okay, if you have questions about 4 and 3, come with them tomorrow, okay? We could definitely talk about those. All right, last 2 examples here. If you're feeling comfortable, guys, feel free to start the homework. If not, just follow me along on these last 2 examples here. So add 1 to each side, right, because we're isolating. So negative 4, absolute value x plus 9, less than or equal to negative 20. Divide by negative 4 from both sides. Now we have the absolute value of x plus 9 is greater than or equal to 5. So this is a possibility, right? So now we set our 2 cases, x plus 9 greater than or equal to 5, or negative x plus 9 is greater than or equal to 5. So we subtract 9, we get x is greater than or equal to negative 4. And on the other side, we divide by negative 1, we get x plus 9 is less than or equal to negative 5. Subtract 9, and we get x is less than or equal to negative 14. So negative 4 would be here, close circle, going to the right. Negative 14 is down here, close circle, going to the left. Interval notation, negative infinity to negative 14. Union, whoops, that should be a bracket. Union, negative 4 to positive infinity. All right. And then here we go, last one. So we add 9 to both sides. We get 3, absolute value of 8x plus 5. Okay, less than 24 plus 9 is 33. Divide by 3 on both sides. We get the absolute value of 8x plus 5 is less than 11. Split it into the two cases. 8x plus 5 less than 11. And then because it's a less than, it's an and statement. So and 8x plus 5 negative is also less than 11. Solving this, subtract 5. We get 8x is less than, what is 11 minus 5? That is going to be 6. And on the other side, we divide by negative 1. So that's 8x plus 5 is greater than, divided by the negative, greater than negative 11. Subtract 5, that's 8x is greater than negative 16. So then x is greater than negative 2. On this side, we divide by 8, and x will be less than, if we simplify that, 3/4. Okay, so 3/4, right? Almost 1, but not quite. Open circle. X is negative 2, is right here. Okay, and then we're just connecting those two things because it's an and statement. So then we would say negative 2 to 3/4 for our interval notation, and we're done. Okay. So please try out the homework, guys. Give it your best shot. I know this stuff specifically can be kind of difficult. Basically, 1.5 and 1.6 are both pretty difficult things. That's how we kind of break up the unit, 1.1 to 1.3, and then 1.5, 1.6. Okay, so come with questions. I'll be ready to talk about it when you guys get back.